Hello everyone. In today's lecture, we will discuss another new concept in the power system stability, that is in the transient stability. That's the equal area criteria. That equal area criteria that's played a very important role. It's a very important topic with reference to the stability point of view under the transient condition, under the of the all power system condition. Because without maintaining the stability of that any single infinite burst, then that by using the equal area criteria, we are not able to keep the system in the stable condition. If the system should not be kept in the stable condition, it should directly affect the apparatus that are connected to them. Even the performance of that system should be directly affected. So let us discuss the first the what is equal criteria, equal area criteria, and what is the impact on the whole infinite burst, that is a single infinite burst system. Okay, so as we all know that is the method that known as equal area criteria is generally used to what, to finding out the stability or to prediction of that stability. Means what, by it is studied but one of the graphical method. From that we are analyzing the what is the stability prediction or the stability analysis, which are generally used to find out analyze the stability of that single infinite burst. So these methods generally is based on the graphical interpretation of that energy stored in the rotating mass, and energy stored in the rotating mass as in the add to the determine if the machine maintains stability after the disturbance. Means what, it generally used for to finding out the graphical representation of that graphical representation of the acceleration and the deceleration of that rotating body, that is nothing but a synchronous motor या फिर synchronous generator ले लो. uh, their acceleration and their deceleration, that totally depend upon the disturbances should be the impacted on that whole system. Okay, so that equal area criteria is the but it generally used to finding out the stability or to finding out the to give the quote on that how that stability, how that what is the stability of that whole system when the system should be the affected, and the many more. Okay, so this method is generally is not is only applicable to the one machine system. That was the single machine system can be connected to the infinite bus or the two machine system. It not is generally applicable for the multi machine system, because the single machine system का ही इसमें क्या होगा, we are able to analyze their acceleration and the deceleration by comparing the input power and their study but the make electrical power with respect to their mechanical power. If there if the both the power should be the equal or to maintain the in the synchronization, then that we can say that that machine should be in the stable condition, because it provides the physical insight to the dynamic, because it's provide a physical insight of that dynamic behavior of that machine. So dynamic behavior of the machine to analyze करने के लिए we generally use that equal area criteria. Okay, so let us consider the first the machine, that is the swing equation. As we all know that swing equation is nothing but what, that P is nothing but what, P is equal to P max into the sine of del. Okay, P max क्या है, this nothing but E into V upon X into the sine of del. That is nothing but the P output of that swing equation. Okay, we can say it is study, but the pi is study, but what is that pi, that is input power. Pi we can read it, it's a input power. We can say it is study, but the pm, that is study, but the mechanical power. Okay, so that m multiplied by that d squared del upon dt square is equal to the pi minus pe. What from where we are getting is study, but the p d square del dt square, because for the any stability purpose for from the equal area criteria we can say that that d del upon dt is always equal to the zero for the stability point of view. So for that case, the m into the d square del dt square is equal to pi minus pe, where the pi minus p is nothing but the acceleration power. Okay, it should be the accelerating or the deaccelerating. Okay, so for that case, that d square del upon dt square is nothing but the pa upon m. That is nothing but the equation number one. Okay, now what we have to do, we have to analyze is the system should be the stable one, that is nothing but a single infinite bus के लिए अपन consider कर रहा है if the system should be the stable है कि नहीं है. So for that case what we have to do, we have to just multiply the equation one by multiplying the d del upon dt. Okay, So increase indefinitely with the time and the machine loses the synchronization. So dt d square del upon dt square is equal to pa upon pa. So from the waveform that we it is study but the del versus t it study but the d del upon dt is equal to 0. As you have to drawn the graph, if you have to changes the del exponentially, then as we all know, system should be the under the stable condition. Whereas when the dl by dt is equal to 0, if the del should be the increases indefinitely, then the indefinitely with the time, then machine loses the synchronization and it study the system is study but the unstable situation. That is study but the point is one. Okay, so in the stable condition, the del undergoes the oscillation, but after it comes down to the stable condition. Means what? That d del by dt should be come down to the 0 at some instant. Means what? ये क्या हो रहा है? Stable हो रहा है some point पे. कौन सा point? That is nothing but the d del. Del का value क्या हो रहा है? It should be the constant one after the some point. It should be the rises. Oscillation will be there, but it's nothing but after the some time or after the sum of the damping out, it should be clear. The system should be the stable one. So we can say that it's nothing but the d del by dt is equal to 0 at a some instant. Okay, so this criteria that d del by dt can be obtained from the equation number 1. So from that d del by dt is nothing but from what we can say that the system should be the stable. For any system should be the stable one. For that case, the given condition should be the satisfied. That is nothing but the d del change in the value of del with respect to time should equal to the 0. That is nothing but the swing equation criteria. And from that swing equation criteria, where that is we are implicate on the equation number 1. So by just multiplying that 2 ds by dt on the equation number 1, so that is equal to 2 ds by dt is equal to d square del upon dt square is equal to 2 pa upon m multiplied by d del upon dt. That's equation number 2. Okay, just integrate with respect to time so that we are getting is equal to d del ds by dt square. Yes, ds by dt is equal to square is equal to 2 by m, having the value is study but the what is the limit of that as del 0 to the del. What is the del 0? That is del 0 to the del. इसका del 0 कितना है? Del 0 point to the del. Okay, वो infinite point ले लिया and that is pa is equal to pa multiplied by d of del. What is pa? Pa is nothing but the maximum accelerating power, maximum power. It is nothing but the p max. Okay, p max into the sine del. What is the p max? That is nothing but the p a is equal to p max into sine of del. Okay, so that pa is nothing but the pi बोल सकते हैं या फिर pm बोल सकते हैं. Pm. Okay, so just implicate here that pm minus p, that is accelerating power, and del 0 is nothing but the initial power angle before the rotor brings to the swing, means because of the disturbance. Means what? Under the stable condition or the under the initial condition, the disturbance should not be there. Under that case, the del value is nothing but equal to the del 0. So under that condition, the stability criteria implies of what? D del upon dt is equal to 0. If that d del by dt is equal to 0, means what? That value, that is nothing but del m is equal to d del by dt is equal to 0. So when the del 0 to the del, integration of the del 0 to the del pa into the ds is equal to the 0. So for that case, that the condition that should be satisfied for the stability point of view under the equal area category, that is nothing but that value of that del 0 to the del with respect to their acceleration is equal to the 0. So for the stability, the area under the graph accelerating the PA versus must be equal to the area under the graph accelerating PA versus del must be 0 for the sum value of the 0, that is nothing but for the positive acceleration must be equal to their negative acceleration or the deaccelerating area. So this criteria is therefore generally known as equal area criteria and is shown in the below figure. So for the equal area criteria, what condition should be satisfied? That the value of that del 0 to the del PA into the ds is equal to d of del is equal to 0. That is nothing but the equal area criteria, where the pa, that is nothing but the pm, is equal to the pi is nothing but what? Pi is क्या हो रहा है? That is nothing but the area under the curve with respect to the del is equal to the area of that second curve. As we all know, this equal area criteria is only applicable for what? Single infinite bus system or the two machine system. उसके अलावा उसको ज़्यादा मल्टी मशीन सिस्टम में सिंगल एरिया इक्वल एरिया क्राइटेरिया applicable नहीं हो पाएगा. Okay, so this criteria is therefore known as equal area criteria for the stability as shown in the figure 6. So from the equation number, from the figure 6, we are going to study about the A1 area, A2 area, this study about the PA versus del graph. PA, acceleration power versus del. So from the stability point of view, we know that the PA versus del, the area should be equal. That's nothing but the equal area criteria. इसका वैल्यू कितना आना चाहिए? 0 आना चाहिए. Okay, as the del value should be 0. So for that case, from the A to the B, that is nothing but the area A1, from the B to the C, that is nothing but the area A2 area. So A to the B, then the B to the C. So A to the B, A to the B, it is nothing but the deaccelerating area, and from the B to the C, this is nothing but the accelerating area. ये accelerating है और ये deaccelerating. Why it is deaccelerating? Why it is accelerating? Because that it is nothing but the mechanical power. Pi is not equal to what क्या है? PM. या अपन इसको PM बोल सकते हैं. Okay, as PM it should be the more than that is nothing but the, that is a PI. This should be the more than that is nothing but a PA. Okay, PA सिर्फ ज़्यादा बड़ा है. That's why it is nothing but the, it's more than there is nothing but the electrical power. That's why it is called as deaccelerating area. Whereas it is nothing but the PI, that is PE, should be more than is nothing but the PM, that is nothing but the accelerating area. If that A1 and the A2 is equal to equal, then we say that is nothing but the, that equal area criteria should be satisfied, and the d del by dt is equal to the 0 for the particular value of that acceleration. So this is all about the equal area criteria. The next lecture we will discuss the application to the sudden change in the power input, or some of the application of that equal area criteria. Thank you so much.